In letter KK, solid zinc sulfide, ZNS, heated over excess oxygen. So here's what I'm thinking. When I'm burning something, heating strongly with oxygen, I want to think in my head that it's following a combustion pattern. I have a little note to myself to look back at letter G. We did something very similar in letter G. Now I know also it will be considered a redox reaction because we'll have things changing charge. But I also think about combustion when something is burning in oxygen. And when something's burning in oxygen, we usually see that as a hydrocarbon producing carbon dioxide. But zinc sulfide isn't a hydrocarbon. However, the sulfide, the nonmetal, will combine with that oxygen to produce sulfur dioxide, and zinc goes then to the oxygen as well, giving us a +2 -2 ZNO. So zinc oxide with oxygen forms sulfur dioxide and zinc oxide. We'll need to take a moment and balance. We end up with 1, 2, 3. I'll start by doubling the ZNO to get the oxygen to be an even number. 1 ZN, so I'll need to double the zincs as well. That gives me 2 S's, so I'll have to double there, and 4, 5, 6, so I can put a 3 in front of the oxygen. Again, not in aqueous solution, so there is nothing to dissociate. What change in oxidation state does sulfur undergo in this reaction? Well, the sulfur started at a -2 as it hooked to the zinc. And over now on the product side, oxygen is always a -2, so a net -4. Sulfur has now turned into a +4 in the molecule called sulfur dioxide. Again, the pattern of change is a combustion or a redox. Either pattern is helpful as we think through that pattern. Think combustion or redox. Zinc started as a +2, ended at a +2, so it did not change oxidation state. Oxygen started at a 0 and went to a -2 in either location here, so that did change oxidation state as well as the sulfur. Sulfur starting at a -2 and ending up with a +4. So the net change is +6. So going from -2 to a +4 means it changed by 6 units on the number line.